My name is Jason Wides. I work at Sealights. I'm the DevOps and Customer Success Manager there. I'm going to be talking to you today about deploying your releases to production with your eyes open. What does this mean? Well, it means knowing what the quality of your product is before you deploy it and not afterwards. And how to automate that process so Jenkins can have the right information and make the right decision to do that deployment for you. What I'm going to be talking about, first, the changes in the industry that I've encountered. Next, the complexity of understanding what the quality of your release is, what automation tools or quality teams are measuring today, what I believe is missing, and the feedback that should be provided back to Jenkins. This, of course, will allow you to do it with your eyes open. Then I'll show you a live demo with a sample of how I do that. And have a session of Q&A, show you some links of the interesting things I did there. And the rest is yours to do. So what is changing? Well, we used to build big monolithic applications, force the customer to install a big product every time we built it. We used to build a couple of times a week, deliver, if it's a good chance, once, twice a month. And then the customer would usually complain that they have to do regression of the whole product, even if they're getting a small fix. Today, a lot of companies have moved over to microservices or smaller modules. And this allows us also to deliver smaller parts of the product and also to release a lot faster. Our pipeline is running faster from the time the developer checks in his code to the point that the release is ready. We can do that many times a day and be able to update our production even every day or a few times a day. The teams have changed. If we used to have separate teams, each in charge of their own responsibility, passing it on to the next team afterwards, not really caring what happens. You know, the developer did his work, the QA will already test it, the DevOps will build it. If something's not running, it means they built it wrong. It's not because I wrote the code wrong. That's also changed. Today we've moved over to smaller teams, which are built up of cross-functional members. They're in charge of the whole cycle end to end. They're responsible for everything from writing the code to testing it, even sometimes deploying it into production. Now, all this is awesome, but it has a cost. What we have a lot of times is a bunch of decoupled microservices with each one has different data sources. We can have queues, gateways, caches, and so on. Now, this does allow us to update the one single service and push that out into production. But collecting the testing information and gathering the metrics and understanding the whole product, whether everything is working correctly together or not, knowing what the quality of our release is very challenging. And I'm going to show you how you can do it. Another thing is because we have these small teams, you have architects there or developers that decide, well, it'll be cool to develop in a different language in our team. And one can be developing in Node.js, and the tests can be running in Java. And the backend can be PHP for web applications and JavaScript in the client. And we need to support all that in the DevOps. Jenkins initially used to be just a build machine which would run the build of the application. Today it's managing our whole cycle for us, and it knows how to manage all these different languages. But again, Somehow you need to gather all the metrics from all the different languages. If I take, for example, just Java, the testing frameworks that you have behind Java. Now, I know you can't read because it's very small because there's a lot of them, but that's their whole thing. Each team can choose which testing framework they want to work with. Some of them know how to generate XUnit reports, which Jenkins knows how to display and show, but a lot of them don't. JavaScript becomes even more complex because not only you've got XUnit, you've got, for instance, TUP, which has turned into a bit of a standard. And here you've got JavaScript on the back end, you've got JavaScript on the client side. Again, the number of frameworks that you have, gathering all the information, understanding what the quality of your product is just becoming more and more complex. So, for this mess, we've got DevOps. Now, I'm not going to talk about DevOps because that can be a number of meetups just on its own. What I'm going to talk about is how Jenkins can receive all this information and handle it. And when most companies have today already Jenkins running CI tools, CD tools, having the flow run automated, everything running smoothly end to end. They can even be deploying into production automatically. But there's a lot of time there's something missing. What's missing is that the question is, how do you know what your quality is? How do you know what you're deploying into production? There's companies, for instance, that decide, well, let's deploy it into production. We'll enable it for a small group of customers. They'll be our beta testers. If there's a problem, they'll tell us about it. We'll fix it quickly. And that way, we can get it up and running very quickly. Other companies think that they're testing. They have certain metrics, but those metrics aren't enough. And then when they deploy out into production, well, something goes wrong, it crashes, and then either they roll back or, again, you're trying to push out a release very quickly. I was even at an interview where the CTO himself told me that he's moving to the point where he's pushing his teams to push everything into production. He doesn't care. From his point of view, it can just fail there. But as soon as it fails, he'll fix it and get it up and running again. They don't have enough time to spend on running all these tests and knowing what's going on. I personally don't think that this is the right way to go. So let's look at what's really missing. Well, what companies usually have today is that they have tests and they check if those tests are passing or if they're failing. But that's just a binary decision. I mean, if a test passes, does it really mean your code is good? How do you know what it really tested? So then you've got coverage. Coverage is what are your tests running in your code. But again, most companies are only testing coverage in the unit test level. That's like checking screws and bolts to understand if your entire machine is running correctly or not. So what I think is missing are the following things. For instance, code coverage on functional tests. Now, functional tests are all different types of tests. They can be system tests, API tests, GUI tests, and so on. Now, if you'd be measuring that coverage, and say, for instance, in one of your tests, the coverage suddenly drops, you wouldn't want to know about that. We've got quality holes. Now, quality holes is a term that we talk about in C-Lights. It's code that has been changed or updated that none of your tests are checking, which means that they're going to get to production without going through any tests. Once again, I'm not sure you want to have any of your code going through to production without being tested. You've got test quality. In test quality, especially in unit tests, because they know that the automation teams are checking the coverage, a lot of times developers will put in a test which is not necessarily testing the right thing, and they're doing it only to improve the coverage report. We've got test duration. How long are your tests taking? And I'm not talking about performance tests. You've got normal tests that you run day to day. If you'd be monitoring it and you'd suddenly see that there's an increase in the time that your tests are taking, it could mean that there's some kind of performance issue, even on the machine itself, not necessarily on the code. We've got test stability. If anybody's heard of what's called flaky tests, It's a test that you can run on your code and it'll fail, and you can run it again and again on the exact same code, and then suddenly it'll pass. Why? Because it's a timing issue or something like that. Just because it suddenly passed, does that mean that your code is good or that your test is bad? Therefore, you've got historical data, and you look at the historical data to really understand what's going on and understand these metrics, and for instance, compare to what you have in production. Okay, not only look at the last build, what its quality is, but really compare it to other builds, to what's been going on, and you can plan ahead and understand how things are progressing. And what about also custom metrics? I mean, maybe you can have your JIRA, the defect system, report how many defects you've got, and if you've got very high severity defects, you can also stop the product from going into production. Maybe the test passed, but there's a severe defect there, and you want to know about it, and also provide that to Jenkins in order to stop the release of the product. So if any of these issues had a major issue, I'm quite sure that you would not want to release your product into production. So what I think is that you need to capture metrics from all your microservices, from all your test types. You need to store the information, compare it, pinpoint where the issues are, have a clear understanding where the issues are and what your quality is. And again, why does this interest DevOps? Because the people in DevOps, the people running the Jenkins, having it all up and running, are the ones that are the last line of defense. And they are the ones that if something goes wrong in production, most likely they're going to get the first telephone call in the middle of the night. And I think it should be everybody's interest that the real quality should be known before deploying to production and understand the information way sooner. So let's understand a few of these issues a little bit deeper. And let's go into the coverage. As I said, unit tests are not enough. If you have a look at this example, you can see that we have two objects. Each was tested on its own, has 100% coverage. But as soon as it was deployed into production, one of these objects didn't exactly work correctly. So, what companies have already today, most companies, is automated unit testing. What they think they need is the automated component testing, integration testing, API, GUI testing. What I believe is that they need to automate and understand everything, including manual tests, including client-side code, JavaScript on the browser side. Also, if you take that information and you look at the history and you understand the code coverage, you can now understand where to invest your time. Investing your time, for instance, in something that has not changed, even if it's not being tested, it's something that's been running there for a while. So the fact of it being in production already means that it's being tested. What you want to look at is where your high risk is. The code that has been changing a lot and is not being tested. That's where the resources should be put. That's where you should be investing your time. Obviously, if you had unlimited resources, you'd handle everything, but we live in the real world, and therefore, you need the ability to see and understand where to invest. Next are the quality holes. Excuse me. Quality holes are code changes, and they can be new code changes. They can be updated code that is not being tested. And again, it's not being tested because companies do not know what their functional tests are covering. And if you don't know what your tests are covering, you don't know what is covered. And it means that you have code that can be going into production, which is not tested. And this is exactly why it's the most important. Because you're making these changes because a customer has either found a defect or has asked for a new feature, or you're providing him a new feature. So he's going to be looking at this code change. You know he's going to be looking at it. It's not being tested. So the person who's actually going to be testing your code for the very first time is your customer. And you don't want your customer to be your automation or your QA team. Then the history. as I said before, if you know your history, you've got which release you have in production, you know what its metrics were. You know what your current metrics are. If you've got 60% coverage, is that good or is it bad? Well, if in production you've got 40%, then it's much better. But if in production you've got 80%, it means it's worse. And comparing to production, you can actually see the code changes that have been made since production to know if those have quality holes. Okay, if those are code changes that were not being tested. You can see that if you're building up your tests, you can be a company that does not have a lot of functional tests, but you plan to build them up. And now, you're even at 0% building them up. You have a plan. You say within 3 months, I'm going to get to a certain amount percentage. With looking at history, you can understand if you're progressing in the right direction. Are you going at the speed that you were supposed to? Maybe something's wrong. Only with historical information you can really see that and understand that. So these are the metrics, and these are what you should be testing. And you should have quality gates. Quality gates are thresholds that you can set for any one of these metrics, which can allow you to understand if your release is sane, if your release is of high enough quality. And now you need to have the ability to provide that information also to the teams, but not only to the teams. You need to have the ability to provide it to Jenkins, to your continuous flow, in order to allow Jenkins to know the quality of that release, to warn you if there's a problem before deploying. If you've got a completely automated session, a cycle, then it can run automatically. And if not, then when you come to deploy that release, you manually try and release that deploy, it will check these metrics and tell you whether you can or cannot deploy the release. So, well, like the picture, woohoo, we've now finally got our eyes open. We now finally know what the quality is. We can know what, when and how to deploy. And I think that's enough talk for now. So I'll put my money where my mouth is, and I'll show you a short demo. In this demo, I'll show you how we are going to be doing what I believe is one of the harder things to do, which is manual testing. And for that, I've got here Jenkins. Just 1 second. Okay. So I've got a lab, what I call a JSON lab, which I set up. And I've got Jenkins here. And these are all different jobs which I play around with. What I have here for the demo, so as I said, one of the hardest things to check from my point of view, which is manual testing of browser code. Okay, so it's the code that's being passed to the browser where either an automated test or an automation engineer is testing your website and having the metrics in order to understand if the code is good or not. I'll just enlarge it a little. So what do I have here? Well, I have a parameter which I've set, which has the amount of time that the test is going to run. Obviously, in the meetup, I'm not going to run it for very, very long, so it's in seconds. I can change this, so by default will be 60 seconds. I'm working with an open source product which exists on GitHub, To Do MVC, if anyone knows it. What I do is I set up first the code. I bring in an agent that we have, which is going to do the monitoring for us. It's going to instrument the files, which means that I'm going to be placing inside those JavaScript certain code, which will allow me to gather the coverage from it. I'll be deploying the code into the location where the web server will be coming up. Then I notify my lab that the testing execution is starting. I need to know where it starts and when it ends in order to know what the coverage was between those 2 points. I'm going to be bringing up the web server. The web server I'm using is a little node module called HTTP stir. It's an open source code which looks in the local directory for an index.html and brings it up as a web server. Now, not sure how many of you know it, but Jenkins monitors the processes that it runs. It does this by passing, because it passes all the environment variables to the process that it brings up, it monitors what's called the build ID. And it looks for processes that has an environment variable with its build ID. And then if that process dies for any reason, it will tell you that there's something wrong, that suddenly it's lost that connection. So there's a cool workaround which I found actually on the Jenkins site. I'll send you the link, I'll provide the link afterwards in the slide. But if you change that build ID, and this I copied from Jenkins site, the token, the name, but it can be anything you like as long as it's not the same build ID. I just called it don't kill me. As soon as you change that, that allows me afterwards, and you can see down here that I kill the server, I can kill it without Jenkins thinking that something's gone wrong, that that process has died. In the middle, of course, I sleep for the amount of time that I told you that I'm going to be sleeping. I'm going to be providing an XUnit report. Now, because I'm doing manual tests, obviously there's no automation system here that's going to be creating those reports. So I'm just echoing it out into a file, saying that it's a one manual test and that it passes. Again, in order to provide my lab the information. But if you're working with an automation tool, you can generate these reports and provide them. I'll be uploading it to my lab, telling the system that the session has ended, and now accessing through an API call, accessing my lab to understand, is that release sane or not? Has it passed or has it failed? And if it passes, I'm going to be typing out, you can deploy it to production. If not, I'll be typing out that you should not be doing that with the reason. Obviously, if this was a live system, then I could have it physically deploying it into production or notifying whoever needs to be known that it cannot be deployed. Is because I'm running tests and I don't want the job to fail. I don't want to fail the job when those tests aren't good. I want them to be unstable. So there's a plugin which allows you to do this. It's a Jenkins text finder. You can search for text. It can be in a file. In this case, I'm going to be checking in the console output itself. And what I'm going to be looking is for that text which I wrote, which is telling me not to deploy it. And if it's set, I'm going to be setting the build to unstable, okay, rather than failed. And I'm going to be reporting that session also out into the lab. Okay? So let's give it a run. Okay, so I think even 30 seconds should be enough. We'll run the build. Now over here, let's also bring up the console. We can see it's instrumenting the code. Starting it now, we can go to the server. And this is a server, the to-do MVC. And now if I start running all different things, saying, let's say, for instance, hello, and we can fix that. And mark this one as cleared. What I'm actually doing now is exactly what some kind of automated tool would be doing. Running the tests. Okay, and there it's finished. Now if I try refreshing this, I'll see it's no longer answering. If I go to the dashboard and refresh it, I'm running now build 59. I can see here, I called it 1.1.59. I can see the coverage is 90%. What I set here inside this is to say that if the coverage is less than 50%, it'll fail. As long as it's more than 50%, it'll succeed. And that's what we can see here, that it's green. And then looking at the Jenkins log, we can see that it said passed. You can deploy it to production. Okay, now let's do another test. We'll do the same thing. This time we'll even give it less time. And you can probably guess, I'm not going to do too many tests. So again, we can go to the server, and it's not up yet. And there it comes. Okay, all I'm doing is going inside it, not running anything, waiting the 10 seconds for it to finish. Okay, it's updating. And now we can see, if I go back here to the dashboard, this time I got 17%. We can see it's red, okay, which means that it failed. Looking inside it, I can see the results. And going back to here, looking inside the logs, we can see you should not deploy this release into production. And the information it's giving me that we've got a failed environment. The manual test is what failed. By the way, also now if I refresh it, before I looked at it before the job was finished, but if I refresh it, now I also have the report coming from Jenkins. And again, this can be any report that I want to upload here, any external information. In this case, I'm reporting the status of Jenkins, and we can see that Jenkins was unstable from within this lab. Also, if I go back to Jenkins, let's say I don't deploy automatically, okay? I can have a job where I've passed the same information. I'm looking for the to-do MVC, what branch, and what build number, and we're talking about 60, okay, 59 and 60. So if I now put in 59, and I tell it to build, look at the console, and we can say 59 I can deploy. And if we go and put in 60, look at the log, and we can see that I should not deploy. It has failed. This time, by the way, it's giving me 2 sets of failures. Before, just to remind you, I was checking if the build is okay or not before the Jenkins job finished, and therefore I only had the status of the test lab itself. Now that I'm running it manually, I also have the details of the external report from Jenkins. So, it's time for Q&A. Here you can have some of the links which I spoke about. The build ID with Don't Kill Me, the project of To-Do MVC, the HTTP stir, the Jenkins text finder, and you're welcome to go to our blog, to the C-Lights blog. Our developers publish there regularly all different very interesting articles. Any questions?
How was the coverage percentage set in the example you gave? By how many times you had for manual test?
Over here, the threshold? Yeah. Okay, so that I come here, and I can see all different things which I can look at. I can, for instance, choose with the coverage trend. Is my coverage dropping or not? What the coverage is, and I can say if it's less than, and I can change this. And for instance, if you're a company and you know that your coverage is currently only 20%, okay, you can set that, for instance, to 20%.
Yeah, but you ran the build twice.
Yes.
One time it was 17%, and the next one time it was...
How did I know what this percentage was? Okay, again, what we do, and I can show you that in Jenkins, in the workspace. We take the JavaScript itself and we instrument the code. Okay, so we create code, which in this case I've put into what's called a JS browser, and then we update the JavaScript itself. This is code from our agent, and we monitor every method and every branch. So as you're accessing it from your client, okay, from your browser client, as you access that point, we know that it's covered. When we instrumented the code, we know what the total build is. So we've got what the 100% is. We know what you've gone through. So we can calculate what the percentage of the coverage is. Okay? Now this, by the way, we don't only do for browser coverage, we do it also for all the types of tests, from unit tests to functional tests to GUI tests and so on. All of them we monitor the coverage, report it, and not only the coverage, also the reports themselves, the tests if they passed or failed and so on. For instance, here in Gradle that had 2 tests, and this was reported automatically to the lab. It's not from a file that I generated. Or in Maven here, you can see this one had a failed test. And you can see the quality holes, for instance, that I was talking about that it found. So here we have things that were changed that were not tested, and I can drill down and start seeing exactly what it is and where it is and so on. Okay, any other questions? Okay, so thank you for your time.